This is the second video for March 2nd, March 7th. If you haven't done the first video, man, you might get lost. So I'll go through the first video to make sure that you know how we ended up with these two solutions. I rewrote. Oh man. I rewrote the initial equation here, and now we want to check the solutions. So here, if we plug in, if we want to check x equals 5, well, we can plug that into our original equation. We would get 5 minus 5 plus 3 over 5 plus 2. That's going to equal 7 times 5 over, really if we want to do this, 5 minus 5, 5 plus 2. And so if you simplify, 5 over 5 minus 5 is 0, plus 3 over 7 equals, you get 0 there. And we have an issue. Here we have 0 in our denominator. We're dividing by 0. That can't happen. That can't happen. So what's happening here, x equals 5, it seems like it's a solution. We solved for x equals 5. It seems like a solution. It's actually not. Well, this is not a solution. This is what we call an extraneous solution. I'm going to go ahead and scribble this out while y'all are doing that. You don't want to worry about this last piece. Scribble that out. Let me go ahead and talk about while I'm scribbling this out. So if we plug in original value and we get 0 in our denominator, it actually is not a solution. We could actually plug in -3, simplifying all that. But here you would get -3 over -8, we're good there. 3 over -1, we're good there. And we would not get 0 here. So what we say is x equals 5, that is not a solution. It's not going to work. X equals -3, that is a solution. That is going to work. And now what we talked about, I'm going to go back to the top. It would be great if we didn't have to check our work every time. If we could say these solutions and be confident that at least one of these is our solutions without having to check our work. And we actually can. What we notice here is, you can look at the common denominator, right? The x minus 5 is the x plus 2. X cannot equal 5 because if you were to set this equal to 0 and solve, like add the 5, if you were to set this equal to 0 and solve, you would add the 5, you get x equals 5. Well, x can't equal 5 because if it did, then you would have 0 in your denominator. Similar thing here, that from the beginning, we can also say x cannot equal -2. We can also get that from our common denominator here. X cannot equal -2, x cannot equal +5. And what this is telling us, what this piece in terms of solving our equations is telling us, is if after we solve, we end up with one of these values, those are actually not solutions. That would be an extraneous solution. So for example, here we said x cannot equal 5. We ended up with our equation to solve for 5. That's not true. That can't happen. We said that here. If this was -2, that couldn't be a solution either because we said x can't equal -2 from the beginning. So this is a good thing to do by looking at our common denominator. Our common denominator is key for these types of equations. If we can figure out our common denominator initially, it tells us what x cannot equal, and it tells us also what we can multiply everything by to get everything out of our denominator. So it's a great thing. Now I'm going to flip to the back page. I'm going to kind of push you in the right direction on one problem, see if you end up, I'm going to give you the solution, see if you ended up there, and I'm going to give you the solutions with the other problems. Let's talk about number 2 here. What we did in class is said, hey, we have actually 3 fractions. Looks like 2, but we really have 3. Because I can write 2 as 2 over 1. And if we want to determine a common denominator, instead of like finding a common denominator, adding all that stuff, we want to determine a common denominator from the beginning. Then we have a minus 3, a plus 3, and 1. They're all different. So really our common denominator would be a minus 3, a plus 3. And so from here we know that a cannot equal -3, a cannot equal +3. All right, so now we have a common denominator. Let's multiply each term by that common denominator. So I'm going to rewrite the equation over here. I guess I can do it like this. So a minus 3 minus 2 over 1 equals 12. A plus 3. I'm going to multiply everything by my common denominator. I'm going to do that in red. Screw. Ooh. And over here, a all right, now let's see what divides out, what we can simplify. Excuse me. In our first term, hopefully we can see that we have an a minus 3 and an a minus 3. Those are going to go away. Those are going to go away. So what we have is a plus 3 times, I would keep this in parentheses, 2a minus 3 minus. Here, we don't have anything that's going to divide out in our denominators. So what we would have is 2 times a minus 3, a plus 3. And here, if we divide the a plus 3's out, we'd end up with this. Now, key piece here. I'm going to simplify a little bit, let you solve the rest. If we have two binomials, we have to do FOIL. If you have a value like this, you have to use distributive property. Got to be careful there. So I'm going to FOIL this, just in case you're like fuzzy, you don't remember it. So basically take the first term, multiply by everything in the second set of parentheses. 2a squared minus 3a. 3 times 2a would give us 6a. 3 times negative 3 minus 9. Here, I would leave the minus 2 and FOIL these binomials first. So a times a would give us a squared. A times 3 would give us 3a. Negative 3 times a would give us minus 3a. Negative 3 times positive 3, negative 9. And then we could do distributive property on the right-hand side to give us this. Clean it up a little bit, we would have 2a squared, the negative 3a plus 6a, positive 3a, minus 9. Even in the parentheses, we can simplify some things. We have a positive 3a and a negative 3a. Those would go away. Minus 2a squared, minus 9. And on this side, we already distributed, so 12a minus 36. Now we need to be careful from here when we distribute the negative 2 to a squared and the negative 9. I'm going to pull that over here. So we have 2a squared plus 3a minus 9. If we distribute the negative 2 to a squared, we would have minus 2a squared. Negative 2 times the negative 9 would give us positive 18. And that's going to equal 12a minus 36. Now we have an equation we can solve, and if you solve it, I'm going to let you do that on your own. You would get a equals 5. Give me a second. So I'm going to let you try that on your own. Here, I'm going to give you the solutions, put you in the right direction. Factor everything. Here, a lot of people didn't recognize that this factors. They both have a p in common, so we can factor out p. If I factor out p from p squared, I'm left with p. Factor out p from here, p plus 1. P plus 1. This already has a p plus 1. So ultimately it becomes our common denominator is p plus 1. If I give this one a p, then I'm good. So our common denominator would be p times p plus 1. And I'm just going to push you in the right direction. If you solve this equation, you'll get p equals 4 and p equals 1. If you solve this equation here, you'll get k equals 6, k equals negative 1. But here you can see that k can't equal 6. So only k equals negative 1. On the next class, we're actually going to have time to work on these in class. So if you have questions, bring those to class, try the homework, and we can try to squash some of those misconceptions. If you have questions, please let me know. Ask me in class, outside class, all of those things.